center points, which was 7 ones, right? Then here we want to move in a way like with the direction which our yield is increasing. Look at here, we have 56, 60, 64, 68. So we want to go through the direction that yield is, like our response is increasing. So that direction is normal, vertical to local contour lines. We call this direction path of steepest ascent. So we talked about the steepest ascent. Now we want to practice on it to see that how can we find it. So what are you going to do is that look at here. So whatever slope your contour lines that you have, you want to find out the vertical line to that like contour line that you have. So we would use the contour line that passes roughly from the center of the experiment. Like here is like, we said that here is the center of experiments, right? And then we are going to have this line, like the vertical line. So we refer to them as local since they describe or capture the region of experimental investigation so far. The experimental region explored the underlying response surface based on our current model. And then after this, we found this line, right? And we see that, oh, it's increasing, and we are looking for the optimum value. And we would go to the step 3, and step 3 is the, if you go to the approach, you will see that it's 3A. We say that if there is no curvature, so we would go to the A, like in the 3A, which is the steepest ascent or descent. So here is ascent because it's increasing. Now we move away from the first design center. So our first design center was here, and we are trying to move away and going to the parts because we are looking for the optimum value. We are looking for the point that is going to give us the optimum value for y. And we can see that it's increasing. Y is increasing over here. So we would follow path of a steepest ascent, and then like vertical to the contour line. And because y estimate is equal to this, it's like that we are gonna move 4.5 unit in x2 for every 2.35 unit in x1. It's like the same things that we have for the I showed you for the slope one, right? So we can say 4.5 divided by 2.35, 1.91 units in x2 for every unit in x1, and then here is the runs. Look at here. What are we gonna do? And look at the first column. We are going to write down for x1, just write down 0, 1, 2, 3, 4, 5. And for x2, we would have like we start from 0, and the next one, we are going to use this equation of x2 is equal to 1.91 x1. So when x1 is 1, x2 is going to be 1.91. When x1 is 2, x2 is going to be 3.83. It's like it's 2 times this, like 3 times this. And we are going to find that x. Then we are going to decode these x1 and x2, right? With the first equation that we had for the coding one. And then we are going to find out our runs. For example, for these ones, this 0 and 0 is like our center points, right? We would say, okay, let's get the average of whatever we had before. And we would say run 5, 6, 7. The average of them, it's going to give us the yield. You don't need to rerun the experiment. And then we start like from these ones we are going to choose. Let's say you're going to choose the first one. It's the operating condition. Like I'm going to do with ATM 134.8. So at this operating condition, you are going to run the experiment. And then let's say you find the yield of 73.3. And then you're going to choose another one. Let's say this one, 90M 144.4. We are going to run the experiment, and the yield that we are going to get is 86.8. And let's say another one, like 153.9. We are going to run the experiment, and we will see that, oh, we found the 58.2. So when you want to name them based on the yield, because we said that yield is increasing. So what are you going to do is, like, for example, if you name this one run number 8, let's say this one is, because it's going to decrease again after 86.8. So what does it tell us? It tells us that the optimum is going to be around these numbers. It's like the optimum operating condition that we are going to have. So remember this 86.8 is going to help us later. Based on this result, the next experiment, 2 by 2 with center point, is designed around run number 10. Why run number 10? Because it gave maximum yield comparing to these ones. You can run these ones as well. It's like that. I just try to minimize the number of the runs and when I'm trying to show it to you. So in fact, we conclude the next runs should be designed around 90 minutes and 144.4 degrees centigrade. So we're going to round it. We can say 145, for example, degrees centigrade or something similar to that one. So now what I'm going to do is that I found a point that instead of having, do you remember run number 1, 2, 3, 4 that we had at the beginning? So right now I want to have those 4 runs, but around the new number, around the new center, which is closer to my optimum, because we want to find out with the response surface method, we want to find out our optimum value, right? That's the final goal for us. So look at here, it's like that here is my new point, 86.8. So this was 73.3. We considered the run, we saw that it would jump to 58 and then it was 86.8. So we would say this is the, I had run like 1 to 7 before, like here you can see it. And then I had, this is the steepest ascent path. So I went through this path and then I found I defined the 3 more runs to just find out this area.